the log base b of x equals y is the exact same thing as b to the y equals x. It's painted on the wall. It's over there above land and gore. I have p on the wall instead of y, but it's the same idea. The definition of a logarithm is painted on the wall right over there. Okay? Couple rules for logarithms. The base of a logarithm has to be greater than 1. And the number that you're actually taking the log of has to be positive. You can never take the log of a negative number. So on your calculator that I just had you get out, if you try to take the log of any negative number, your calculator won't do it. Okay? You cannot take the log of any negative number. So the x, the number that's in the x position there on the screen in the log equation, has to be positive. And the logs that you're doing on your calculator right now, the b is 10. Your calculator only knows how to do logs with a base of 10, as far as you know, with the log button anyway. The other buttons can do a couple other different things. We'll get to that later. All right. So, this logarithmic equation, written as an exponential equation, would be 4 to the second power equals 16. So that would be 4 to the second power equals 16. That is how you turn a log into something you've seen before. The base to the other side power is going to equal that number where the 16 is, what the number you're taking the log of. Okay, now for practice, I want you to rewrite those two logarithms into exponential equations. Okay, here's what I get. 3 to the fourth is 81. 3 to the second is 9. Any questions on that? That should be fairly straightforward. Just getting used to working with logarithms at the most basic level. Sir?
Are we going to run into something that...
Now, what I'm going to show you is a way to do a logarithm on a calculator that is not base 10. We know that the log base 3 of 9 is equal to 2. It says it right there in that third example you did. The log base 3 of 9 equals 2. Okay, so then I rewrote it in blue. Here's how you would do that problem on a calculator. On your calculator, you would take log of 9 divided by log of 3. So I want you to take your calculator and see if you can take log of 9 divided by log of 3 and get an answer of 2. Look at the 3 examples we did at the top of this screen. Now I want you to go backwards. I want you to take 4 to the x equals 256 and write it as a log. Can we do that? Look at where the numbers go. See if you can piece it together. What would it look like? Well, we would have log. What would our base be? 4 of 256 equals x. Well, we can do log base 4 of 256 on our calculator. I just showed you how to do it. So we can solve the equation 4 to the what power is 256 by changing it to a logarithm. So log 256 divided by log 4 should be 4 on your calculator. That's what you should be getting. We did that problem twice yesterday. 4 to the 4th is 256. But what this does for us is it takes us back to 2 days ago when I said that we could not solve 3 to the x equals 5. Remember I said you couldn't solve it? Now you can. How would I write 3 to the x equals 5 as a logarithm? We just did it with 4 to the x equals 256. How would we do it with 3 to the x equals 5? I'll help you. Log. That's the extent of my help. What's the base? 3. What are we taking the log of? 5 equals x. So now you can do that on your calculator, and by taking the logarithm, we can now solve this equation, 3 to the what power equals 5, which I know, since we didn't solve it 2 days ago, has been keeping you up. And if you do it right, you should get 1.46-ish. All right. So the value of logs, what we're going to use them for, at least early on, is it takes that x out of the exponent and it moved it down to the regular level where we can solve it. Because you can't solve for a variable if it's in the exponent. It doesn't work. Okay? So the answer to the mystery equation from 2 days ago is approximately 1.46. 3 to the 1.46-ish power is really close to 5. All right. So those are some more. We're going to skip those since you're pretty much getting how to turn those into logs. Those were just some more exercises of writing exponentials into logs. You could practice those at home on your own if you need more help with those. All right. So now what we're going to do is we're going to solve some equations for a variable. Log base 4 of n equals 5/2. If it's written as a log, try to write it as an exponential. If it's written as an exponential, maybe try to write it as a log when you're solving. So to rewrite log base 4 of n equals 5/2 as an exponential, I have to go back to the beginning of today, the beginning of the section, and see how I did that. And what I did was I went 4 to the 5/2 equals n. Like that. Okay, we just did that 10 minutes ago. And now that's a calculator question. 4 to the 5/2 power. 4 to the 5/2 is 32. On the right side, I have 8 to the 4/3 equals n. And 8 to the 4/3 is 16. Just simply rewriting the logarithm as an exponential and solving. Now I want you to try 2 of them all by yourself. I want you to solve those 2 equations for x. So there's the answers to those, 27 and 3. Any questions on those 2 examples? Okay, moving on. Now we're going to look at an equation where there's a log on each side. And these problems can get extremely complicated. Not today, of course, since we are babies on this topic. But they can get very large and hairy. But today, we're just dealing with the most simple problems. This type of problem that you see on the screen right here has a log on each side. which is very similar to yesterday when we had similar bases for our exponential equations. When you have a log on each side, the log of something equals the log of something. The somethings are what we care about. And so you can ignore the logs and simply set the somethings equal to each other. That only is going to work when you have one log on each side and they have the same base. In this case, we have log base 3 of a parentheses equals log base 3 of a parentheses. And in that case, you can set the two parentheses equal to each other. Okay? And then you're solving like you were back in 7th grade. Solving for x. Subtract the 2x over to the other side. And then negative 9 halves. Okay, now here's where we have to go back into this section. Everybody understand where the negative 9 halves came from? Nicole, you with me? Okay. As I said at the beginning of the section, you cannot take the log of a negative number. I had you take the log of a negative number on your calculator. You can't do it. So what you have to do in these type of situations is you have to make sure that the answer we get is not asking us to take the log of a negative number, because if it is, it's not going to work. So when we put negative 4.5 in, call me crazy, but I think we get negatives up there. Negative 4.5 times 2 is negative 9. And negative 9 minus 7 is negative 16. So those two parentheses are going to be negative 16s, which means that the answer doesn't work. Which means it's a guppy. You cannot take the log of a negative number. If you need to be reminded of that, just try it again on your calculator. And it won't work again. You have to check your answer to make sure that it is you're taking the log of a positive number. Because when we solved for it, we weren't dealing with logs. None of that red stuff up there has anything to do with logs. We ignored them. So when we were solving in red, we were not using logarithmic properties. So anything went. Now we have to make sure that our number works with logarithmic rules along with the standard algebraic rules that are in red. And it didn't. Let's try again. Log base 4 of x squared equals log base 4 of 4x minus 3. Again, we have a log on each side, which is a good thing. We can ignore them and simply focus on the two parenthetical expressions. So I'm going to set x squared equal to 4x minus 3. Now we have to know how to solve that, which means that we're going to have to dabble into chapter 5. Which means that we're going to have to know how to factor using the monkey method or the quadratic formula. We're going to have to bring back things from first semester every so often. And when I say every so often, I mean every day. It's just different things from different chapters. So the first two have to multiply to x squared. The last two have to multiply to 3. And since my nose and my mouth have to be negative 4, I'm guessing that 3 and that 1 have to be negative. All right. If my factors are x minus 3 and x minus 1, what are my two solutions? 3 and 1. Carly, you with me? All right. So my two solutions are 3 and 1. Now you have to check and make sure that they lead to positive parentheses, and you could probably do that in your head. Look up at the top. Does a 3 give you positives in the parentheses? Yeah, what's it give you? 9. So it's good. How about 1? Does it give you positives? Yeah, it gives you 1. It's going to give you the same number in each one. So both are good. Your turn. Try that one.